When The Big Bang Theory first aired in 2007, it wasn't clear whether audiences would connect with four socially awkward scientists talking about quantum mechanics, comic books, and cosplay. But not only did the show become a pop culture phenomenon, it also did something extraordinary. It introduced millions of people to real physics, not in the way a textbook would, but through banter, blackboards, and beautifully nerdy conversations. Sure, The Big Bang Theory was a sitcom. It exaggerated stereotypes and relied on laugh tracks, but beneath the humor was something remarkable. A commitment to getting the science right. This wasn't accidental. The show employed UCLA physicist Dr. David Saltzberg to ensure the accuracy of the equations scribbled across whiteboards and to vet scientific dialogue for credibility. In an era of misinformation and pseudoscience, that's no small feat. But how much real physics made it into The Big Bang Theory? Let's take a tour. 1. Schrödinger's cat and the art of dating. In one episode, Sheldon uses Schrödinger's cat to explain the uncertainty of dating to Penny. The reference isn't just name-dropping. Schrödinger's famous thought experiment, about a cat in a sealed box that is simultaneously alive and dead until observed, is a staple of quantum mechanics. It dramatizes the concept of superposition, that quantum particles can exist in multiple states until measured. What's brilliant is how the show uses this to describe a real-life situation. Penny and Leonard are in a romantic gray area, uncertain if their relationship will work. Sheldon, oblivious to emotional nuance but fluent in quantum theory, proposes that until they open the box, i.e., go on a date, the relationship is both a success and a failure. In a few lines, the show educates viewers about a notoriously mind-bending theory while also forwarding the plot. That's not just writing. That's quantum storytelling. 2. String theory, a running gag with real gravity. Sheldon Cooper is a theoretical physicist devoted to string theory, a field that attempts to reconcile general relativity with quantum mechanics. Throughout the show's early seasons, Sheldon is often shown working on massive whiteboards filled with complex strings of symbols, many of which were double-checked for accuracy by Saltzberg. String theory posits that the fundamental particles of the universe are not point-like dots but tiny vibrating strings. Different modes of vibration correspond to different particles, just as different guitar strings produce different notes. It's beautiful, it's ambitious, and, as critics point out, it's also unproven and possibly unprovable. By centering Sheldon's career on string theory, the show subtly reflects the current debates in physics. Some episodes even touch on the frustrations of working in a field where experimental confirmation is nearly impossible. In this way, The Big Bang Theory captures not only the facts of physics but also its emotional landscape, the uncertainty, the hope, and the intellectual loneliness. 3. The Doppler effect costume. Remember the Halloween episode where Sheldon dresses as the Doppler effect? He walks around making woo woo sounds to mimic a passing siren. It's one of the show's funniest and nerdiest gags, and it's rooted in real physics. The Doppler effect is the change in frequency of a wave relative to an observer. It's why an ambulance siren changes pitch as it zooms by. It also explains the redshift in light from distant galaxies, which is a key piece of evidence for the expanding universe. By turning a serious scientific principle into a Halloween costume, the show made the Doppler effect unforgettable for a generation of viewers. It's absurd, yes, but it's also accurate. 4. Nobel Prizes and the long game of science. In the final season, Sheldon and Amy win the Nobel Prize in Physics for their work on superasymmetry. This storyline is entirely fictional. Superasymmetry is not a real field, but it captures something very real, the dream of scientific recognition. Throughout the series, the characters wrestle with the politics and egos of academic life. Sheldon's constant craving for Nobel-worthy discovery reflects the ambition many scientists harbor, even as they toil in obscurity. The show doesn't always glorify this pursuit. Sometimes, it questions whether genius is worth the cost of human connection. But by the end, when Sheldon accepts the Nobel and finally credits his friends, the message is clear. Science is not a solitary endeavor. It thrives in community, collaboration, and even chaos. That's a truth more profound than any equation. 5. Real equations, real effort. Most shows would fill a chalkboard with nonsense symbols. The Big Bang Theory didn't. When you see equations on the set, many are taken from real research papers. Saltzberg often used current developments in physics for background details, so you'd find references to Higgs boson theory, loop quantum gravity, or dark matter tucked into the scenery. This dedication to realism didn't go unnoticed. Professors would pause episodes in class to point out equations. Fans began asking about the real physics behind the jokes. Suddenly, a sitcom was sparking curiosity in string theory and particle accelerators. In a world saturated with fiction, The Big Bang Theory used its platform to quietly teach. 6. Beyond the Blackboards. Women in Science. Amy Farrah Fowler, played by Mayim Bialik, a neuroscientist in real life, and Bernadette Rostenkowski, a microbiologist, brought real diversity to the show's portrayal of science. Their inclusion wasn't just about representation, it was about realism. Women have always contributed to science, though their stories are often overlooked. Amy and Bernadette weren't sidekicks. They were accomplished, driven, and deeply nerdy in their own ways. The show challenged the stereotype of science as a male-only domain and opened doors for broader conversations about gender, ambition, and workplace dynamics in STEM fields. Conclusion. Laugh tracks and light cones. The Big Bang Theory may not have turned everyone into a physicist, but it did something rare. It made physics part of everyday conversation. It showed that science can be funny, emotional, messy, and human. It reminded us that behind every equation is a person, behind every theory is story. Yes, it had flaws. It leaned on stereotypes. It simplified complex ideas, but it also respected its subject matter in a way few sitcoms ever have. In the end, the real physics of The Big Bang Theory isn't just in the equations, it's in the curiosity it sparked. Somewhere out there, a kid heard Sheldon ramble about quantum tunneling and asked, "What's that?" That question is the beginning of science. And that's no joke. Word count. 10 words. Let me know if you want a shorter version, citations, or added humor.